With its 10-degree beam angle opening, the main component of flow is almost parallel to the beam direction. Therefore, the ADC is less sensitive to angle deviations caused by misalignment or angular flows from obstructions in the water being measured. In the following slide, we'll take a look at the ADC's tolerance for flow angles, where measurement error starts to be introduced, and how much error is associated with flow angles. Due to the measuring principle and the location of the ultrasonic transducers, the ADC is relatively unaffected by angular flows. Field tests have shown that measurements were unaffected by angular flows up to 10 degrees. In the field, it is possible that the measurement error could be as much as 6%, with a flow angle of 20 degrees, and approximately 8% with a flow angle of 30 degrees. Quality control parameters determine whether the measurement is valid. Parameters include signal-to-noise, correlation, velocity gradient, and standard deviation. Measured values that meet the internal quality check criteria are saved. For example, if the measurement time is set to 30 seconds, the ADC collects a maximum of 30 values for each sound pulse. At the end of the measurement time, the ADC checks whether at least 50% of all measured values meet the associated criteria. If the 50% standard is not met, the measurement is rejected and the user is prompted to repeat the measurement. If the measured values are confirmed, the ADC calculates the mean and standard deviation for the measured velocities in the cells closest to and farthest from the sensor. Based on the result of the calculation, the final velocity is determined and shown in the display. A quick quality check, or QQC, helps make sure the system is ready for use and will give reliable and accurate measurement data. This 30-second test can be conducted in the office prior to taking the unit in the field. Quality checks can also be done while in the field environment with a field quality check. Its results are then saved with the discharge summary file. Measurement guidance refers to on-screen warning messages and accompanying recommendations. These appear in the event one or more quality parameters are not met. In addition to quality parameters, signal-to-noise, correlation, velocity gradient, and standard deviation discussed on the previous slide, percent discharge for the measured vertical, correlation, flow angles, velocity distributions, and total depth are compared against user-definable quality thresholds. For example, if calculated discharge for the measured vertical is greater than 5% or the user-defined threshold, the ADC will display a warning and the option to accept or insert a vertical. Note, the user-selected action is recorded and included in the discharge summary report. Now we'll take a look at the QReview software and we'll review a discharge measurement. We will now open a discharge measurement file that was downloaded from an OTT ADC. In the QReview application software, there are 3 graphs. The top graph depicts the mean velocity over the total depth for each vertical. And we'll open up a discharge measurement file so we can take a look at actual data. So here you can see that the arrows in the top graph are showing the velocity as compared to the y-axis and the direction. The middle graph represents the discharge corrected for the width of the measured section, and the line shows the absolute discharge and the bars show the relative discharge. A green bar shows a discharge that is less than 5% compared to the total discharge, and a red bar shows a discharge for the vertical that is greater than 5%. The lower graph depicts the cross-sectional profile and the area used in the discharge calculation, and that is shown here with a red line. QReview also shows the individual vertical profiles. On the right, we can use the up and down arrow to move to additional verticals. Down in the lower right-hand corner of the screen, we see an abbreviated discharge measurement summary that shows a quick snapshot of your measurement, including the total discharge, the width, area, mean depth, and mean velocity. Detailed information about your measurement is available in the discharge summary, including measurement settings, summary results, and instrument information. The file also includes the ISO 748 discharge uncertainty results and depth calibration information. Field quality check results are presented here and shown with a pass-fail criteria, as well as the actual results, the value, compared to the thresholds. The quality threshold settings are also noted. ADC warning messages, including user corrective action, are also listed. In addition, the QReview summary report also shows potential quality issues that were identified when the measurement was imported into the QReview application software. Finally, the QReview discharge summary file includes a time series file of the average values over the measurement interval. This report may be downloaded into a CSV file by clicking on the Save button. It can also be downloaded as a report text file, or you can go to the Export drop-down menu and select XML. You can also select the report that you'd like to export. Now let's review the Q&A flags, raw data, and a few basic editing features. To take a look at the flags, we'll go back to the visual graphics. You can see here that we have triangles. Each triangle notes a potential quality issue. If you click on the flag, you'll notice that information is displayed about the flag. For instance, here at vertical 19, which was at position 50 feet on the tag line, the discharge was greater than 5% of the total. If I click on another flag, I can see that a similar flag occurred at vertical 21. Let's go over here to our bank. Here I can see that we had a potential quality issue that resulted from having a flow angle greater than 20 degrees. Now if I'm interested in learning more about what that flow angle was, I can simply click on the flag and it will take me to the vertical data. Here in the vertical data, I can view what the actual angle was for that vertical, and I can see here that it was 38.5. I can also see other information about the measurement that occurred at that particular vertical. For example, the standard deviation, the signal to noise, the average correlation for beam 1, beam 2, mean velocity, depth, area. The Verticals Data tab also shows what corrective action was taken at that vertical. So for instance, if I go down to vertical 29 where we had the error, I can see what the user in the field did out at the measurement. So I can see that the user repeated the measurement and then they saw a boundary issue warning, and then the user went ahead and just accepted that boundary issue. Now let's say I'm interested in looking into the data a little bit more. I want to know more about what happened at that particular measurement. From here I can go to the time series data. In the time series data, I'm actually looking at a 1-second measurement. So in the upper graph, I click on the vertical that I'm interested in. So I can click on, for example, here, vertical 1. In the lower graph, the 1-second time series measurements or raw measurements from the ADC are shown. There's additional information in these 1-second measurements that is not shown in the verticals data that we just reviewed. For example, when we look at signal to noise, correlation, and signal amplitude, I see the values from both beam 1 and beam 2, whereas in the verticals data, it was an average of both, and it was an average over the measurement interval. The QReview software also allows you to make some basic edits. So for instance, we'll go to the edit box here, and we can make edits to our first edge, our last edge, including the depth, the position, the factor. We can also mark values as invalid or valid. When I first opened the window, I saw that the vertical number 1 was marked as invalid because the box was not checked, so I can always mark that as valid, apply and recalculate, say OK, and then I can go back to my graph and I can see that the information, the measurement from vertical 1 was applied. Now, for instance, let's say I want to remove vertical 1. I can go to my edit box, I can deselect the valid, check mark, apply, recalculate, and OK, and now I can see that vertical 1 was removed. It is also possible in the edit window to change calculation methods from midsection to mean section. We'd like to thank you for viewing the OTT ADC webinar, and have a great day. Thank you.